In this video, I'm going to illustrate how to expand logarithms. So here's our first problem. Let's expand this. Here's a log property you'll find useful for these types of problems. The log of a product equals the sum of the individual logs. Likewise, the log of a quotient is equal to the difference of the individual logs. There's a shortcut you can use for these types of problems. If the variable is in the numerator, like x to the fourth and y, the log is going to be positive. If the variable is in the denominator, your log is going to be negative. So using that shortcut, we're going to have positive x to the fourth log base 3 x to the fourth. The y variable is also positive, so we have plus log base 3 of y. The z variable is minus, so the log is going to be negative for that one. Minus log base 3 of z squared. Here's another log property we can use for these two exponents. If you have the log of variable raised to a power, you can bring that exponent out in front of the log. So we can bring the exponents out in front. So the 4 goes in front and the 2 goes in front as well. So this equals 4 log base 3 of x plus log base 3 of y minus 2 log base 3 of z. And that's your answer. Problem 2. Okay, on this one we've got a couple square roots. I'm going to do the outer square root first. So we have x cubed square root of yz to the fifth. That's all to the 1/2 power. Now I'm going to change the other square root. Yz to the fifth to the 1/2 power. This is all to the 1/2 power. The next step would be multiply the exponent through. So you're going to have 1/2 times 1, which is y to the 1/2. 1/2 times 5 is z to the 5/2. And we have this outer 1/2, so we're going to multiply that through as well. So you got 3 times 1/2, it's x to the 3/2. You have 1/2 times 1/2, it's y to the 1/4. And 5/2 times 1/2 is going to be to 5/4, so z to the 5/4. So what we have here is the log of product of three variables. So here's another property. The log of three variables multiplied together is the sum of the individual logs. Log base 10 of x to the 3/2 plus log base 10 of y to the 1/4 plus log base 10 of z to the 5/4. From here we can use that exponential property again. So we can move all of these out in front of the logs. So we got 3/2 log base 10 of x plus 1/4 log base 10 of y plus 5/4 log base 10 of z. Problem 3. This one's another square root, so let's start by rewriting the square root as being raised to the 1/2 power. Log base 10 of x squared minus 144 times x plus 4 to the fifth all over x minus 12, and this is all to the 1/2 power. From algebra, you might remember a difference of two squares. We actually have that here with x squared minus 144. We can rewrite x squared minus 144 as x squared minus 12 squared. Our a is x, and our b is 12. So you have x plus 12, x minus 12. So we're going to replace the x squared minus 144 with x plus 12 times x minus 12. So this becomes log base 10 of x plus 12 times x minus 12 times x plus 4 to the 5th all over x minus 12. This is all to the 1/2. So we can cancel the x minus 12s, and now you have log base 10 of x plus 12 times x plus 4 to the 5th all to the 1/2 power. Next, let's multiply that 1/2 through the brackets. So you're going to go 1/2 times 1, that's going to be 1/2, and then 1/2 times 5 will be 5/2. Right, so log base 10 of x plus 12 to the 1/2 power times x plus 4 to the 5/2 power. So let's use that log of a product property to write that product as a sum. So we have log base 10 of x plus 12 to the 1/2 power plus log base 10 of x plus 4 to the 5/2 power. From here we can use the exponent property again. Bring that exponent out in front of the log. So we can bring the 1/2 in front of that log and the 5/2 in front of this log. So then we have 1/2 log base 10 of x plus 12 plus 5/2 log base 10 of x plus 4.